Welcome back, folks. All right, we're going to keep on moving with our first chapter of physics. And in this video, we're going to talk about measurement. As we learned last time, one of the defining characteristics of physics is the ability to go out and make measurements. That is the core of what physics is, designing experiments, making measurements, and learning more about the world. So, what makes a measurement? Well, a measurement should have two parts, a magnitude and a unit. And I love to poke fun at people that leave their units off of their homeworks or their tests or quizzes or whatever it may be. Really, their lab reports, that's the most important one. Because you need both of these. If you only have one or the other, what you're essentially giving me is nonsense. If I were to tell you how tall I am, I wouldn't say, oh, I'm about 6 tall. That has no meaning. If I said, oh, I'm a little under 6 feet tall, I've given you a magnitude and a unit. That number 6 means nothing without the unit. And I'm not actually 6 feet tall. I'm about 5'10", so a little under 6 feet. But even that 5'10", we're so used to these colloquial just local phrasings. Whenever I say 5'10", it's implied that is 5 foot 10 inches. But if you're writing this information down and handing it over to someone else, you need to specify that unit. A number without a unit is meaningless. If I tell you I've got about 100 in the bank, I mean, you're probably going to assume I mean dollars and be like, oof, man, teachers really are hard off like they told us. They need to pay him more. He's only got $100 in the bank. But what if I meant million? I've got $100 million in the bank. All of this information is crucial. You need a magnitude and a unit to make a measurement make sense. And I could throw units at you too. I could tell you I am feet tall. Well, feet, you're going to say how many. How many and of what define a measurement? Or how much of what? And it's crucial. We're going to need these units because the units will combine in interesting ways that we'll find out. So if we were to measure, say, the size of a room, we might get 12 feet by 15 feet by 10 feet. And just like you multiply the numbers together, 12 times 15 times 10 is 1,800, you multiply the units together as well. We're going to be doing math with units in this class. It might be odd at first, but I think you'll adjust quickly, or at least I hope you will. And if not, I will help you every step of the way. So just like we multiply the numbers, we multiply the units, and our answer then is 1,800 cubic feet. And this is just like algebra, the way that you would take a variable, a letter, and combine it in mathematical fashions. That's the same idea. Nothing in this course is going to go beyond the ideas of algebra. So I hope you are familiar with algebra. If not, reach out to me. I'll give you some good videos, some tips and tricks of my own to at least get the basics necessary for this class. Now I used feet in that example, but for the most part, we're not going to use feet, inches, miles, and so on very much in this class. There will be a couple of times we do, but in general, there are more convenient units to use. And one example I love to bring up right here is the British unit of mass. So does anyone know what the British unit of mass is? Well, I'll tell you what, it is not pounds. Pounds are actually a unit of force, not a unit of mass. Slugs are the British unit of mass, and I will guarantee you we will not be using the unit of slug to discuss anything's mass in this classroom. I would have to look up what a slug even was in terms of what it compares to in grams, or kilograms, which is what I'm much more familiar with. These weird British units don't combine very easily. The units we are going to be using are things like meters for length, grams for mass, seconds for time, and that one probably sounds familiar at least. And when it comes to force, we're not going to be using pounds very often. We'll be using newtons. And as you guys might have guessed, these are all metric units. Scientists like to use the metric system, and it's not just an arbitrary choice we decided to make life difficult for American school children who have to learn a new set of units. there is a fundamental utility to these things, and that is metric prefixes. So metric prefixes help describe metric units. We can take any of these words, meter, gram, second, Newton, and we can add a prefix, a little word that goes on the front of it, and it changes its meaning slightly. And so I've listed some here in this brief table. Right here in the middle would be meter, and I left this column blank. So here is the word that you would, or prefix you would add. Meter is actually special. That is the base one. So you could replace that with gram or second or Newton or whatever metric unit we were using. And if you are using just meters, well, it just means you have one of them, or 10 to the 0. Metric prefixes are based on powers of 10, which we will come back to in our last video as to why this is important. But anyway, you add these prefixes, they would have these letters that would go in front of meter. So like for centimeters, meters are abbreviated with the letter M. I didn't write it there because M doesn't get used for grams or seconds or newtons. But if we wanted to write centimeters, you put a little c in front of an M, cm for centimeters. And that means 1/100th of a meter, or 10 to the minus 2 meters. All of these prefixes have a meaning, and they have to do with powers of 10, tens of something. Deca would be 10 of something. Hecto would be 100 of something. Kilo is 1,000 of something. Mega is 1,000,000 of something. And this goes on and on and on and on, up into Google, or I think there's even things beyond that. I always like to ask what's the one above mega. It would be for a billion. And it would be gig city. And a lot of people can remember these from computer storage, which is getting very common to everyone to be familiar with megabytes, gigabytes, terabytes, petabytes. And I've listed 0, 1, 2, 3, but really once you hit 3, they kind of jump in groups of 3. 3, 6, 9, million, billion, trillion, so on. And it goes in the small direction as well. Deci, like a decimal, 1/10 of something. Centi, 1/100th of something. Milli, micro, and it goes nano, pico, femto, and so on and so forth. We'll mostly probably be using kilo and centi the most commonly, and milli. But I'd like you to just know that these things exist because they make conversions very quick. So if we want to know how many centimeters are in 2.5 meters, well, we know that 2.5 meters, well, a decimeter is 1/10, so there's going to be 10 times more. We multiply by 10 or just move a decimal. And then if we want to go from decimeters to centimeters, again, 10 times more. We move the decimal over, and we get 250. Or alternatively, you can set up ratios. You can say, well, I know I've got 2.5 meters. There's 100 centimeters in 1 meter. Because these are smaller, there's more of them. You multiply, the units cancel, and you're left with 2.5 times 100, 250 centimeters. We'll look more at unit conversions in a moment. But this is why we use metric units. It's very quick and easy to move these things around. One last example. How many kilometers are in 1.2 million, or 1,200,000 millimeters? Looking back at that chart, we can see we're going from millimeters, that's the unit we're starting in, which is on the order of 10 to the minus 3. We're going 2 kilometers, which correspond to 10 to the positive 3. This is 1,000th, a fraction, to 1,000 of something. It's like going 6 decimal places, 6 powers, minus 3 up to positive 3. 6 powers of 10, or you can think of a power of 10 just as a decimal place. So we take our number and we move 1, 2, 3, 4, 5, 6 decimal places, and boom, we've got 1.2 kilometers is what 1.2 million millimeters is equal to. And to make sure you're moving your decimal place the right direction, just remember a big prefix has a little number, kilometers, only 1.2. A little prefix will have a big number, millimeters, 1.2 million. That is the way that they balance each other out. These are equal, but depending on what sort of prefix we're using, the number changes. All right, so all of these units I've discussed so far are called fundamental units. Units like meters, grams, seconds. They're fundamental units because they can't be split into other units. They are the smallest sort of amount that you can describe something with. Very similar to how atoms are the fundamental building blocks of matter. And let's see, there's another type that I'm going to get to see why. Let's consider this question. So if you travel 120 kilometers in 3 hours, what is your average speed? Now, you don't have to worry about knowing these equations or how to plug them in. We'll get to that next chapter. But it would be found like this. The velocity is equal to distance over time, or displacement over time. So we would have the distance we traveled, 120 kilometers, the time it took, 3 hours, and we do math with the numbers. 120 divided by 3 is 40, but you also do math with the units, just like we saw on the last page. And so we have kilometers divided by hours, and our answer is 40 kilometers per hour. Now that kilometers per hour is a little different than things like meters, grams, seconds. Kilometers per hour is a derived unit. It is made out of other fundamental units, specifically the kilometer and the hour. We have combined two fundamental units to make up a new type of unit. This defined distance, this defined time. Velocity is defined with derived units. They're made up of other types of units, distance over time. Now, as I said, we might need to convert units at times, so let's look at some unit conversions. And specifically, I want to convert 1 meter per second to miles per hour. Meters per second is a unit we'll be using a lot in here. However, you're probably not too familiar with it. Miles per hour is probably much more familiar to you. So this is just a useful, quick conversion, and we'll start off our next video with that. Maybe you can try this on your own before we begin and before you tune in to watch the next one. So see you guys soon.